Yeah. Hello. Hello. Hello, Ryan.
Hello?
Hello. Yes. Remember yesterday we talked about this BFS. Yes. It is jumping game. Okay.
Yeah.
So let me just review it. Let us review this a little bit. So we have look. We have a list of numbers. Yes. 1, 0, 2, 2, 1, 4. Okay, and then possibly let's do it. Yeah, let's do it 1 here. Okay, so if we start at this position, like look, yeah, we can go this way two step. We can go backward 2 step. Okay. So one way of jumping to this 0 is, Eric, look at me.
Yeah.
Look, is to here, and then I'm on 1, and then go back to this, and go back to 2, then here. Or you can do this 2
There's many ways.
here, and then jumping 1 here, right? Yeah? So remember this BFS, we search the tree for if we are at 2, right? We are at this position 2. So now I can go to this position, which is to the 1, or go to this position. This also 1, yeah? So this is the left one, that's right one, that's right.
I was just learning about the BFS.
No, I will introduce another concept later. Left one, okay? And then now if it's left one, and then I can do this, yeah, which is 0, or this, which is left one, yeah. You see? So the point is that every time I take the node in the tree and I expand the children, which is phase 2, right? And I take this and I can expand it.
Are we today we're learning DFS?
Yes, great job.
Because
Yeah.
find DFS.
Yeah. Okay, so let's DFS. So yes, today we are talking about DFS. So what's DFS? Can you?
Dinosaur first.
Okay, you get this right. This is first, and that's the search, right? BFS is breadth.
Dino first search.
Breadth first search, and D is depth. Depth first search. Okay, depth.
I know depth.
Yeah, depth first search. This is
You
breadth
can
first
talk
search.
about it.
So again, using these, look. So we're talking about this, right? So if we are at 2, so how does it reflect this to this problem? You need to look at me, okay? Otherwise, I'm not talking. Look, 2. We are at 2.
Doing it me.
Okay, Ryan, you need to be careful, okay? Pay attention. 2. Then I can go to 1. And then I search this to 2 again, and then 2. You see? So it's the depth first search is that I pick a path, yeah, and then I go as far as I can, right? Do you see? Yeah. So let's do it in code, okay? So how do we do it? How do we do it?
Depth.
Depth.
Space. DFS.
Where the
Yeah. Space. DFS. Bracket N comma S comma visit.
No, yeah. Yeah, don't look at my notes, you just look at my board, okay? So look. Here, DFS N start for the list. This is the list. This is the map, yeah? The list. The numbers. We're talking about the numbers. And S is the starting point. Right? So now we first of all we need to check if the starting point is 0. Then we say if the starting point here is already 0, it means we have reached the destination, right? So what should we do now? We return. Can you guess here? Return what?
Return true.
Yeah, return true because we already visited it, right? Okay, so now if I'm at this position S, so how many choice do I have?
Return false.
No. How many choice do I have, Eric?
What?
If I'm at one position, how many choice do I have?
2.
2, yeah, because I'm jumping forward or backward, right? So there are 2 choices. So therefore, I in -1, 1. That's a list. Minus 1 is
Return false.
not yet. -1 is jumping backward. 1 is jumping forward. Then now we need to check.
Looking at me.
We need to check if the position has. We need to calculate the next position. Next will be equals S, right? Currently is S. Then plus I times NS, right? Yeah? So what does this mean? This means that I'm at this position, and if this number is 1, then n square bracket s is 1, and then -1 or times 1 plus s. Now currently at this position, right? Now we need to check if this position is within the boundary. Yeah? If next bigger than 0 or bigger or equal than 0 and next smaller or equal than length n, right? No, smaller than length n. You can't jump out of the boundary. Also, we need to make sure the position has not been visited before, right? So we can do this by passing a notebook function, right? A notebook dictionary, which it will be, let's call it notebook, and then that's using a set, right? And then the column here. So now, and if this next position is not in notebook, so it means we haven't visited the position before, then what do? We first of all, we add a position into the notebook, right? So notebook dot add next. Now, okay, so now we have the next. No. Step first is do you still remember recursion? Yeah? Calling itself. So now we need to call the function.
Very, very, very first
Look,
day.
if DFS, we're calling this function, and what should I be passing here? Next position is
S.
no. S is current position. What's the next position?
I.
No. What's the next position? Next, right?
S at I times n.
So next, I pass in the next, and then what in the notebook? If this function return true, then I return true, right? Return true. Okay? If this return true. Now, remember, we need to remove this position, remove this visited, so that the next step, so the next time, yeah? Next time, because there are two positions, possible steps. So I need to remove this for the next move, right? If I jumping backwards, which I didn't find a solution, then I have to jump forward to try, right? Okay. So and then what's next? What's here? What should I do here? Return
False.
false. Yes, because after this, if we can't find it, we return false, right? Okay. So do you see it?
Yeah, I see it.
Yeah.
I see it.
So look, this notebook, when we add it, we need to remove it, right?
I see
Yeah.
it.
It's better. You can put this here, but I don't think it's quite necessary because look, if this has to come in pairs, if you add it to the notebook, then somehow you need to take it.
Print
Yeah.
BFS. Huh? What do you mean?
So
Here.
yeah, it's optional. Okay. For this one, you don't because we already returned true, so we don't need to remove the item from the book. But this one, do you understand why we need to remove it here? Look, suppose if I'm jumping backwards, right? Jumping backwards. This is jumping backwards, right? And I put this number, I put this 2 in the notebook. I jumping backward, and I found out I can't get the solution. I can't find the path by jumping backwards. Then the next one I should be jumping forward, right? If we jumping forward, then you need to unmark and mark this position you have been visited because this belongs to the past, jumping backwards. And then you need to take it out, right? So this is depth first search. So do you see it? Look, if I given a S, if I can find the past, then
print.
yeah. Don't and I would go through. I will go as deep as I can by following the path until I found one. Right? You see? That's called depth first search. Yeah. It's like a maze. Yeah. You see a maze? Yeah. You are here entering. You are entering. You are here. Yeah. And then here is exit. Exit. And then there are some paths here. Yeah. And then depth first search is that. Okay, if you can find a path, you just go as deep as you can, until you find it. That's called deep. Yeah, I know. That's the what's breadth first search? Breadth first search is like that.
Deep.
No. Breadth first search is like that. Okay. What's the next step you can go? Okay, here, and then I can go here. I try to go here, and then I pick the one here, and I go further. Yeah. I know. This is DFS. Depth first search. BFS is like that, yeah. And then you retreat, and then you go more. You see? Do you understand? So it's like you are here, and then you are trying to expand your territory until you find here. Do you see it? Yeah. That's called BFS. And DFS is you find the path, you just try to go as deep as you can until you hit the obstacles, and all you are in. You are in a place that you don't find any more exits, right? Okay, so do you get it? This is DFS and BFS. DFS, okay?
So you need to print bracket BFS.
That's just to test how how our solution is. Okay, so any questions?
No.
Okay, do you want to say goodbye?
Bye.